Okay, here we are. We're just going to do a brief review on this. And I want to point out some interesting spots again. As I was talking before, you can see that we're accelerating up through here. This is increasing returns up to this point here that we call the inflection point. And then this is where diminishing marginal returns begins. That's the point of diminishing marginal returns. And then we start to decelerate, so we get decreasing additional returns from this point clear up to this point. And this is going to give us a window, as I was referring to earlier, on where to operate our businesses so that we can maximize profits, so we can hone in with more data, more cost and revenue data, which will actually tell us where to pinpoint where the maximized profits can be. And this, of course, is just taking into consideration that we're changing one input. And with computer science, this has become something that is definitely a technical science, in the fact that we can have multiple variables out there to distinguish and determine where the maximum profit is on our production function. That's more in, we can take a 100-dimensional type of a calculation here in a form of a production function with many inputs and actually figure out where the maximum profit is generated at. So if you're interested in economics and the real inner workings of it, this is just a very simplified version of it, just changing one input. Generally, as a business person, you're juggling all kinds of variable inputs at one time, and you're trying to determine where that is, and it becomes a whole lot more difficult thing. But with the generations of computers that we have now, we can actually come up with a fairly solid answer of where that maximum profit can be had. And that's some of the technical analyst's job. And economics with accounting background can actually give these big firms a really good jumping off point to where they can maximize their profits. But anyway, these are really important in the fact that this is our inflection point. So as I was talking about earlier, we actually could draw a line right here. If I had a straight edge, I would draw a line right here. You guys have had me in class. Just visualize that as a straight line right there and right here. Oh boy, this is harder than on the board. And if we work from, we want to increase our production because it's more efficient with every unit of output, given that our marginal product is increasing. And here's what our marginal product will do, and I want you to prove it to yourself. But if you map your marginal product out, it's actually going to have a function that looks something like this. So this is your marginal product. And that's how we found, remember, that's how we found our inflection point, is that where that's maxed out right here. That if we go up on our production function, that's where we are as far as the inflection point, right there on our function, on our total product, the production function. Okay, and we call this stage 1. And to keep it simple, we'll call this stage 2 of production. You know, every instructor's got to play with all the toys they have. It doesn't mean that it works out that well. And this is stage 3. Okay, And with the production function and the data that we have right now, what most economists, and let me get to another graph so it'll look a little bit different, but I want you to be able to map this out too. Okay, let's see if that works. No, it didn't, but I've got it here, so this will work. Anyway, is that as I've been explaining to you, we actually have a name for the area where your crazy cousin Eddie operates, and that would be stage 3. It's totally irrational to operate where you're actually decreasing output. All right, so every unit of input right here, we go past this line here, every unit you're declining your output even more and more. You're accelerating the negative to the negative side of your output if you cross this line right here. All right, and if anything in stage 1, we are getting more bang for our buck. We're becoming more efficient with every unit of output. We see this line is turning up. This function is turning up all the way up to your inflection point. So what that tells us is that the only place that we want to operate in, if we're rational, is right between these two lines here. So if we were to draw a line here, like that, this is the area where a rational producer will actually apply fertilizer. We can use that for different things, other inputs. One example would be a McDonald's. Okay, so if you can visualize this a little bit, and we're talking about our levels of input by level of number of employees. As we add employees along this line here, if we only have 1, we can have an output of this level right here. If we add 2, then you see how it's accelerating right here. If we add 3, we get to here. See how that's working? And until we get to this point, we keep accelerating our output as we add workers. And somewhere in this area right here, there's the sweet spot called the profit maximization point. We haven't determined that yet. And you can visualize this as we get out here and continue to add workers out this way. That's where there's too many cooks in the kitchen. There's more people at the cash register than there are cash registers and that sort of thing. And we actually become less efficient. So you can think of it in that terms as well. Now you can add some things to this thing. Now McDonald's has added, and many of the fast food restaurants have added online ordering and kiosks, and that has actually moved this production function so we get, it moves like this. Has moved the whole production function. Moved it out here. So if we add those technological advances, a lot of times this is what's happening, is this production function is actually moving out to the left with fewer and fewer workers. So that's how the effect of technology and possibly some other types of things that we might implement in our business decisions. So hopefully that makes sense. If it doesn't, let me know. I wish you were in the classroom. We could have some fun with this thing with lots of examples and that sort of thing. But if this doesn't make sense, maybe I can come up with an example that would work for you. And give me a call, give me an email. I wish you well. We'll have a little bit of homework due with some data. It's going to be a little more complex than the simple one we went through. But if you have any trouble with that, give me a call. Thank you.